Okay, we're looking at exercise 6c from the second year mechanics textbook on projectiles. Okay, so we have got a stone being projected at an angle of 15 degrees below the horizontal with an initial speed of 30 meters a second, and we want to know basically how long it takes to hit the ground. So how long does it take to get from where it started down to B? Okay, so I think I'm going to only need to look at the vertical motion for this. And sorry, question 12. Okay, and you're probably more used to taking upwards as positive, and that's absolutely fine. So I'm going to start this by taking up as positive. I might change my mind shortly, but yeah, if you're used to taking up as positive, let's have a think about that. So it's starting with a speed at an angle of 15 degrees, a speed of 30 degrees, 30 meters per second. So I'm looking vertically, so I want that component. Okay, so that is opposite the 15-degree angle. So its initial velocity vertically is going to be 30 sine 15, and I can see from this it's going downwards, so that's going to be minus 30 sine 15. Its acceleration is going to be due to gravity, and again that's going downwards, so that's going to be minus g, which we've used a lot. And its displacement, well, it's starting 14 meters in the air, so it's going to hit the ground when its displacement is minus 14, and I'm after t. I want to know how long that takes. So now I've written all that out, it actually makes a lot more sense to take down as positive. Now, it's perfectly fine to stick with up, as long as you're careful with all those negatives. And you might, rather than sort of chopping and changing and getting confused, you might just want to always take up as positive. But if I take down as positive, because all three of those things are down, gravity is working downwards, its initial velocity is downwards, its displacement is 40 meters below where it started. But you can stick with all the negatives. So I'm going to use S is ut plus a half at squared. So 14 is 30 sine 15 plus a half a, which is gt squared. So that's looking a little messy, but actually it is just, if I wrote it out properly, so it is just a quadratic. Yeah, there's my t term, there's my t squared term, there's my constant. So it is just a quadratic. So I'm going to make it equal 0. So I'm going to bring the t squared term to the front, then my term in t, and just be really careful that t is not inside the sign. So it's 30 sine 15 and then all multiplied by t. Then I'm going to minus the 14. I'm going to go straight to my calculator and use quadratic solve mode. And I'm just going to enter the half g and the 30 sine 15 in when I enter my values of a and b. So I'm definitely not going to lose any accuracy from rounding. So I'm going to enter A as a half times 9.8. I'm going to enter B as 30 sine 15. And I'm going to enter C as minus 14. And I get T is 1.074. Yeah, that'll do, I think. And T is minus 2.659. Okay. So obviously, t can't be negative, so in the context of this question, that one just does not make any sense. And because I've used g, it's really only sensible for me to give t to two significant figures. Yeah, because I use g, we use g as 9.8 always in maths. So if I'm only using g to two significant figures, I can only really say my answer is to two significant figures. Okay, so that's not so bad compared to some of the other questions we've seen. 6 marks, really not too bad. Okay, and then B is only worth 2, and B, I want the distance AB. Okay, so what do they mean by that? Well, rough diagram. So there's A and there's B. So the path the particle actually took was curved like that, but there's A and there's B. The distance AB, I imagine that's a straight line, that's what they want. They just want the distance between A and B. So I've got a right angle triangle. I know it started 14 meters up, so I have that. So basically I need that distance there, the horizontal distance it travelled, and then I can just use Pythagoras. Okay, so So let's have a think about the horizontal motion. So its initial velocity horizontally, so that component there, so that's adjacent to the 15 degrees. So that's 30 cos 15. I want to know the displacement horizontally. Yeah, that's what I'm after. Oh, sorry. I want to know the displacement. I'm after that distance there, so I can use Pythagoras. So that's the horizontal displacement. Now I just need to be a bit careful with time because I've rounded time to 1.1 seconds, but as this is part of my working, I'm actually going to go back and use the slightly more accurate. So I've still got it on my calculator, so let's just use that. Okay, right. So when I'm looking horizontally, we ignore wear resistance, so there is no horizontal acceleration. So it's constant velocity. So v equals u. The velocity is 30 cos 15 at any point horizontally. So I can just use displacement is velocity times time. So its horizontal displacement is its horizontal velocity times time. So, you know, that can't be right. Okay, let's try again. Right, 1.0745 times 30 plus 15. One. Right, so I'm just pausing because, oh, ignore me. I was thinking, I know that's not the right final answer, but that's not our final, is it? Right, so that's giving me 31.1 meters, let's say. But in fact, I'm just not going to clear that answer from my calculator. Right, so AB is the square root, I'm just using Pythagoras now on this triangle here. So it's the square root of 14 squared plus 31.1 squared. So it is, so that's squared plus 14 squared, root answer is 34, sorry, just can't see that, is 34 meters. Okay, so that would be the distance AB that they wanted. Okay, let's just quickly check that. Yeah, 34.1.1, awesome.